Hi folks. In this activity, we'll be trying to create an equilibrium mixture by reacting an aqueous solution of iron 3 nitrate with an aqueous solution of potassium thiocyanate. When these two are mixed together, the iron 3 ions react with the thiocyanate ions to give a dark brown looking complex of iron thiocyanate. The nitrate ions and the potassium ions are called spectator ions because they're not involved in the reaction. This is an orange looking color solution, and that is colorless. And when they're mixed, we get this dark brown looking color of iron thiocyanate complex. Then what we'll do, we'll then change the concentrations of the iron separately, and then you'll be asked to use your knowledge of Luc Chatelier's principle to predict in which direction the equilibrium will shift and what you expect to see. The same thing we would have done for a thiocyanate ion. So these are the two solutions that we'll mix together to create our equilibrium mixture. This is colorless potassium thiocyanate, and this is orange looking color iron 3 nitrate. So we'll take a little bit of the iron 3 nitrate and drop it into this solution of potassium thiocyanate and observe. You can see that immediately a dark brown looking solution is formed. So here is our equilibrium mixture. In this mixture, of course, iron ions, thiocyanate ions, and the iron thiocyanate complex will be in equilibrium. I already created one like this, and I have divided up into 4 portions because we need to do 4 experiments. The first experiment involves adding a little bit of iron to the solution. But before we do that, we go back to the board and try to recall Luc Chatelier's principle. Luc Chatelier's principle is very easy. What it means is this: if I add something to the reactant side, the equilibrium will shift in a direction to lessen the effect of that. So if I increase the concentration of either of these, what do you think will happen? To lessen the effect of either of these, one of them will combine with the other one to form the products, and the equilibrium will shift in that direction. So the first thing we'll do to demonstrate how the equilibrium can be shifted from one direction to the next is by adding some iron 3 ions to the mixture. So before we add iron 3 ions to this equilibrium, I want you to predict in which direction the equilibrium will shift and what color changes will be produced. Okay? All right. Here we go. This is a sample of iron inside here. Pay attention. What did you notice? You can see that this solution turned darker in color. Pause. In this second experiment, we'll be adding thiocyanate ions to the equilibrium mixture. Again, make a prediction as to which direction you think the equilibrium will shift and what observations will be made. Okay, here we go. What do you observe? Notice how the solution turned darker when thiocyanate ions are added to it. In this third experiment, we will be adding sodium hydroxide to the equilibrium mixture. But sodium hydroxide is not a part of the equilibrium mixture. It is neither a reactant nor a product. However, sodium hydroxide provides OH ions. And in the presence of OH ions, ions are removed in the form of a precipitate of iron 3 hydroxide. That is one of the ways of removing an ion from solution, is by precipitating it out of solution. Another way, for example, if you had H plus, for example, right? We can remove that by giving it an electron, so it forms a hydrogen atom. Now this is not effective anymore because it's changed to hydrogen. Or we could have reacted that with OH ions to give you H2O. These are some different number of ways of removing an ion from solution. So in this case, this guy will be removed, some of it will be removed and locked away in the form of iron 3 hydroxide. What do you think will happen if you do that? In this case, you're removing a reactant. What do you think will happen? Make a prediction. This is our equilibrium mixture. And now we have poured some sodium hydroxide solution into it. Make a prediction. See that? This solution turned lighter. You can see some precipitate of iron 3 hydroxide being formed, and if you leave that overnight, you'll see the precipitate will form under the influence of gravity. In this fourth experiment, we'll be adding a solution of silver nitrate to another sample of the equilibrium mixture. In this case, like the one before, we will be removing this ion by allowing it to react with silver ions. The silver nitrate solution is providing the silver ions that will combine with this guy here. So this is what will happen. Silver ions will combine with thiocyanate ions, all these are aqueous, and we are going to get a precipitate of silver SCN. Then this is a precipitate, is in the form of precipitate. So the addition of silver ions to the solution will remove that ion from the equilibrium mixture. So we're removing reactant. Using Le Chatelier's principle, what do you think will happen? And what color changes will be observed? We'll now do that final experiment. So this is the color of our original equilibrium mixture. And this is a solution of silver nitrate that we'll add. So make your predictions. You can see there that the color of the solution became lighter, and if you look carefully, you can see that a white precipitate was formed there. Leave this for a few hours, you will see that the precipitate will be more visible at the bottom there due to the influence of gravity on those small particles there. So that concludes the first part of our tutorial. In the other part of this tutorial, you will see how I have simulated all four of these reactions and how the analysis of what you observe have been made and profound explanations are given for all these changes that you observe using Le Chatelier's principle.
the equilibrium mixture that was obtained in our demonstration was created by adding iron 3 nitrate solution to a solution of potassium thiocyanate. According to this ionic equation, the nitrate and potassium ions are not effective in any way in this reaction. As such, they're called spectator ions. Basically, this is how the equilibrium was established. It is formed by iron 3 ions reacting with thiocyanate ions to produce iron thiocyanate, and these three species were in equilibrium. The color produced was similar to this one here, and that is predominantly due to the color of iron thiocyanate. The color of the equilibrium mixture depends on the concentration of iron thiocyanate. As the concentration of the iron thiocyanate increases, as depicted by these figures here, you can see as you go downwards the concentration of the iron thiocyanate increases. As such, the equilibrium mixture gets darker and darker. We will use a change in the intensity of the color of iron thiocyanate to indicate the direction of equilibrium shifts. These figures represent the simulations of the 4 demos that were performed. In this first demo, iron 3 ions were added to the equilibrium mixture and a darker solution was obtained. The same thing happened when thiocyanate ions were added to the equilibrium mixture. A darker solution was formed. In demonstration 3, when sodium hydroxide was added to the equilibrium mixture, a reddish-brown precipitate was formed and the solution became lighter in color. The reddish-brown precipitate that was formed was really iron 3 hydroxide, and this equation shows how iron 3 hydroxide is formed between iron 3 ions and hydroxide ions. The sodium ions from the sodium hydroxide are considered to be spectator ions. In this fourth demonstration, when silver nitrate was added, the solution turned lighter in color and a white precipitate of silver thiocyanate was formed. And this equation here shows how silver thiocyanate is formed by the reaction between silver ions and thiocyanate ions. So these here are the 4 simulations of the 4 demos that we have just performed. These figures, along with Luchat's principle, will enable us to explain the observations that are made in each of those 4 demonstrations. In the first demo, iron 3 ions were added to the equilibrium mixture, as indicated here. And of course, the solution turned darker in color. When iron 3 ions were added, we were actually increasing the concentration of a reactant. According to Luchat's principle, if the concentration of a reactant is increased, then the equilibrium should shift to the right to reduce its concentration. For that to have happened, some thiocyanate ions must have reacted with some of the added iron 3 ions to form some more iron thiocyanate, and as a result of which the solution, as indicated in this diagram here, turned darker in color as a result of the buildup of iron thiocyanate. 2 of the points to note are these. Because you've added iron ions to the equilibrium mixture, even though the system tried to reduce its concentration remained a little bit higher. Number 2, because thiocyanate ions were being used to react with iron ions to form iron thiocyanate, the concentration of thiocyanate declined. In this second demo here, thiocyanate ions were added to the equilibrium mixture, as indicated in this figure here. And when that happened, like in the case of the addition of iron, the solution turned dark. Also, again when we added thiocyanate ion, we are increasing the concentration of a reactant. And according to Luchat's principle, if the concentration of a reactant is increased, to reduce its concentration, the equilibrium must shift to the right. For that to have happened, some amount of iron must have reacted with some of the thiocyanate ion to form iron thiocyanate. And because a higher concentration of that was produced, it caused the color of the solution, like the one before, to turn darker as depicted in this diagram here. Two other points. Because some ions were used up to react with thiocyanate ions, the concentration of iron went down, but the final concentration of the thiocyanate ion remained a little bit higher. In this third demo, we added sodium hydroxide to the solution. As depicted in this diagram, effectively it is the OH ions that produce the change, because these are spectator ions and they are not involved in the reaction. The observation was that a reddish-brown precipitate of iron 3 hydroxide was formed and the solution turned lighter. This equation shows how iron 3 ions are combining with hydroxide ions to form a precipitate of iron 3 hydroxide. How do we explain these color changes? In this case, the hydroxide ions were able to reduce the concentration of iron 3 ions by locking them off in the form of a precipitate of iron 3 hydroxide. So effectively, we have removed iron 3 ions from the solution. According to Luchat's principle, if the concentration of a reactant is decreased, then the system should shift to the left to replace the reactant. For that to have happened, some amount of iron thiocyanate must have decomposed, and because of this, the concentration of the iron thiocyanate got less, and that's why the solution turned lighter in color. Finally, silver nitrate was added to the equilibrium mixture, and that is depicted in this figure here. Again, the nitrate ions, because they are not effectively involved in any reaction. The observations that were made are 1. The lightening up of the color, and 2. The formation of a white precipitate of silver thiocyanate. And this equation shows how silver ions react with thiocyanate ions to form silver thiocyanate. How do we explain these observations? Like what happened before, only in this case, silver ions reacted with some thiocyanate ions to form a precipitate of silver thiocyanate. Effectively, we are actually removing thiocyanate ions from the solution and locking them away as a precipitate. Note that one of the ways of removing an ion from solution is by reacting it with something that forms a precipitate. In this case, the concentration of a reactant was reduced. Therefore, to replace that reactant, the equilibrium had to shift to the left. For that to have happened, like what happened before, some amount of iron thiocyanate must have decomposed to produce some amount of thiocyanate and some amount of iron 3 ions. For that reason, the solution turned lighter. And of course, this is the precipitate of silver thiocyanate. So other things to note, the concentration of iron got higher, the concentration of this got less. All right, I hope that suffices. When you add iron to that, it reacts with thiocyanate ion there to form more of the iron thiocyanate. That's why the solution looked dark like that. Same thing when you added thiocyanate there. Some amount of iron reacted with that to shift the equilibrium to the right, forming more iron thiocyanate. That's why the solution looked darker here. When you added hydroxide ion to the solution, it reacted with iron ions, locked them away as a precipitate. The concentration of the iron got less, and to replace that, iron thiocyanate decompose, trying to replace that, but at the same time produce some of that because of the decomposition of that guy, which normally contributed that color, the solution turned lighter. Same thing here, only that silver was able to lock away thiocyanate iron, and to replace that, this decomposed, and the same explanation can be made as to why this color turned light like that. So these are the equilibrium concentrations of iron 3 ions, thiocyanate ions, and iron thiocyanate ions in the equilibrium mixture. We're adding iron 3 ions to it. So what do you expect to see? You add something, it will spike. What will happen with the equilibrium? The equilibrium will shift to the right. So for it to shift to the right, this has to react with that. So you expect this to decline and that to increase. We're adding some thiocyanate ion. If you add thiocyanate ion to the equilibrium, to reduce it back to normal, iron 3 ions will react with it, and the equilibrium shift to the right. Thiocyanate ion, you expect to spike. This guy here should increase because the equilibrium shifts to the right. The iron concentration gets decreased because it's reacting with this guy to produce that. Now, look what happens here. We're adding OH ions, but OH is not a reactant. But it decreases the concentration of iron 3 ions by forming a precipitate of iron 3 hydroxide. Thus, the concentration of that decline downwards. See that? And because of the decline, this guy here decomposes to try to replace it. Okay, that got a little bit replaced, and in so doing, that one also got increased. So addition of silver, what does silver do? It locked these off as a precipitate. This guy here decomposed to replace the thiocyanate ion, but at the same time, more iron was produced. I hope that these demonstrations, the simulations, and the explanations were able to make you have a more profound understanding of Lushat's principle. Thank you for listening.